Hi, I'm the Amateur Logician from amateurlogician.com. I hope you are doing well. In this video, we're going to study inductive logic, and we're going to preview complete enumerative induction, partial enumerative induction, and finally abstractive induction. Now recall, in deductive logic, deduction brings certainty. It extends our knowledge, and if we have true premises and we follow the laws of deductive inference, then the conclusion from a deductive argument is guaranteed to be true. That's precisely how it extends our knowledge. But this means that such a deductive argument presupposes already known, justified, or probable premises. And the question is, where do we get these premises? Take the famous deductive argument, all men are mortal, Socrates is a man, thus Socrates is mortal. How do we get the major premise, all men are mortal? How do we know that premise is true? Well, the simple answer is that we learn via experience. It's just an empirical fact that when we observe human beings that they die. They don't live forever. Now, this raises issues of empirical evidence, of generalization, that is, how do we move from the fact that we observe some men who die, that we can say that all men will die? And finally, an issue of abstraction. How do we even form the concept of man in the first place, or of mortality in the first place, let alone combine, so to speak, the subject men with the predicate mortality? Now, the proposition, all men are mortal, is strictly speaking called a synthetic proposition in the scholastic tradition. Or in other words, we can say that it is empirical, or it's empirically driven. We discover the truth of that proposition through observation. But also note that sometimes we can get premises in an armchair way. Sometimes the predicate of a subject is so logically linked that we can just intellectually realize that objective link without added empirical evidence. And this would be an analytic proposition. For example, you can find such propositions in praxeology. We might say that such propositions are non-empirical. However, note that an analytic proposition is not just true by definition. This type of viewpoint, where we're comparing analytic propositions with synthetic propositions, is different from the modern definition of what it means to be an analytic proposition. So in contemporary analytical philosophy, an analytical proposition is just true by definition. But here, an analytic proposition takes a broader, wider scope. It can be true not just by definition alone. Yet leaving those cases aside, most of the propositions we deal with are synthetic. But even with the analytic proposition, so to speak, they're grounded in the empirical fact that we are actors in this world. We're embodied beings in this world, and we learn with our experience in the world. But still, again, most propositions are synthetic in nature. How do we know the temperature water boils at, for example? There's no way to deduce that without empirical evidence. That is, without learning from experience. This is why induction is really so important. Deduction is important, but it relies on inductive logic in the sense that it presupposes that we already know some good premises, and most of those premises come from induction. So this leads us, first off, to complete enumerative induction. And this is pretty simple. This just counts up every member of the group. And because it's complete, some wouldn't even consider this, strictly speaking, a type of induction. Regardless, it's just looking at everything there is to look at and says, hey, all of them have this property, so therefore they all have this property. Pretty straightforward. For example, all members of this household are, let's say, agnostic. We're talking about all the members of this household, so we can say, hey, all of them are agnostic. We've surveyed each and every member of that household. each and every one of them said they were agnostic, so therefore every member of that household is agnostic. Or consider, for example, all marbles in this bag are red. Again, we're talking about all the members. We look at each and every marble and it turns out to be red. Or take the example, all parakeets in this house have beaks. Again, we're talking about all of them. We looked at each one of them, so we can then conclude that all of them in this house have beaks. But here is when things get interesting, and that is partial enumerative induction. And this is really the foundation of empirical disciplines. It's vital to biology, chemistry, and so forth. And here, it's counting up some, but not all, of the members of the group. Now, partial enumerative induction is stronger or more reliable when dealing with predicates that have an intrinsic or necessary connection of some type. And this is actually a very, very important point as we consider examples and the so-called black swan problem. A lot of philosophers and logicians have been overly skeptical of induction. We really shouldn't be. We should be cautious, but not overly skeptical. Consider these examples. All men are mortal. Now, it's impossible to have observed all men, but nonetheless, all of us, I think, are sure this is a good proposition and a true proposition. Moreover, we're even considering the future, right? And we haven't observed the future. So I'm going to die, although I haven't observed it. You're going to die, but I haven't observed that. We've only observed some men who have died. So how do we go from a some statement to an all statement? Well, one thing is for sure, we need a sufficient number of cases observed. But what is a sufficient number? That's actually a tricky question. It depends. One thing we can say is that sometimes we don't need a huge sample. Other times we do need a big sample to be more or less sure of our inductive inference. How about this example? Water, or all water, is H2O. Now, these two examples are very, very different from finding out all the members of the household are agnostic. And that's because we're dealing with some kind of intrinsic, maybe even necessary connection between the subject and predicate. So consider water and H2O. We're dealing with the essence. It is the essence of water to be H2O. If you see water, it's going to be made out of H2O, period, end of story. If you see H2O, it's going to be water, period, end of story. And this relates to what the late logician and philosopher Sol Kripke called an a posteriori necessity. That is, we know the truth of water is H2O, not in an armchair way, but based on empirical observation. Before, people didn't know that water is H2O. So it's a posteriori rather than a priori. But it's also a necessity because water and H2O really go hand in hand. If you have something that's not H2O, it's not water. It can never be water. And so a partial enumerative induction, reaching the conclusion water is H2O, actually doesn't need a huge sample. But what about all men are mortal? Well, that is an attribute, not an essence. We're also on firm grounds to say that this proposition is true even though we have never observed all men and we will never observe all men. But it is less certain than the proposition water is H2O. For the next example, consider all swans are white. If every swan we have observed so far is white, it seems we can conclude that all swans are white. But here, we have a problem. Insofar as we observe a black swan, then it cannot be the case that all swans are white. But we raised a difficulty here. This black swan problem is not a reason to be radically skeptical of induction. So all swans observed have been white, thus all swans are white. But note that the attribute of whiteness is accidental. There's no intrinsic connection. There's no necessary connection. Moreover, swan is a genus, not a species. So this is accidental. This attribute is an accidental attribute. And so this proposition, all swans are white, we can be less certain of as being true than all men are mortal, and definitely far less certain than water is H2O. So when we consider a partial enumerative induction, we have to understand there are degrees. Next we have abstractive induction. And this is a means to reach an essence or nature of something, where we consciously limit the scope of our thinking positively and negatively to zoom in or bring forth something. And there are two aspects of abstraction, a negative aspect and a positive aspect. It's a matter of concentration, so to speak, to eliminate what's not important or essential and focus in on what's important or essential. Consider men are rational animals. Consider the nature of man. Men have various accidental features such as skin color, height, or whatnot. Hence, if we want to consider the nature of man, we negatively disregard such things. On the other hand, positively, we retain the fact that man can think, that he has an intellect, and that he has a body. He's an animal, so man is a rational animal. Now, this ability to engage in abstract induction is through what is called the agent intellect. Now, like partial enumerative induction, abstractive induction generalizes. Abstractive induction can help set the stage for partial enumerative induction, moreover. For example, by getting us to recognize a particular subject, which then we can predicate with various properties. And abstraction really is the foundation for thinking. If we couldn't abstract to reach universals, we couldn't really think. Indeed, we would be stuck on particulars and individuals without being able to unite them and reason about them. Each time we saw a man, we wouldn't know him as a man, as embodying, so to speak, that universal concept of mankind or manhood. Abstraction is an intellectual process by which we can move away from particularities or singularities. Now, I am the amateur logician from amateurlogician.com. In this video, we previewed abstractive induction, and this allows us to focus our thinking to develop concepts and ideas. We can move away from particular things to consider classes of things, to consider groups of things. It also helps us pinpoint what the nature or essence of something is. That is, what best describes a group of things and their commonality with each other. And this also directly ties into partial enumerative induction. We rarely observe all things of a particular kind of thing or a class of things. Still, we can generalize to think about that class of things. As we previewed, there are kinds of partial enumerative inductions that are stronger than others. When we're thinking about, say, the nature of an electron as such, or water as such, we're on extremely strong grounds to generalize with a small sample. Other things, such as an accidental feature of things, is less strong as a type of induction and is so better with a larger sample to then infer about the population as a whole. And in fact, when it comes to accidental features, it might be that the various things of a class of things have contradictory attributes. That is to say, they differ, okay? For example, maybe they differ in the various colors. But we could make some kind of statistical statements about X percentage is this color, X percentage is that color, and so forth. Additionally, we talked about complete enumerative induction. Here, every member of the group has been observed. Finally, we considered how deduction depends upon premises. Often these premises are found with induction for synthetic propositions rather than analytic propositions. Now, if you enjoyed this video, if you found it useful in any way, please consider giving this video a like. I would really much appreciate it. You can visit my website at amateurlogician.com. You can also follow me on X. That'll be cool.